Okay. Today we are going to discuss integrating Spark SQL with RDBMS. Integrating Spark SQL with RDBMS. Okay. So here we are doing integration with SQL, Spark SQL. So this is our Spark SQL application. Spark SQL application. Spark SQL application. So through this application, we can integrate with any RDBMS. We can integrate with any RDBMS. So this is, assume this is MySQL, and this is Oracle. This is any database. Assume any database, any database, any database. What I want to do through this Spark application, I want to connect with MySQL. So we need one special software here. We need one special software, JDBC. JDBC. We need a JDBC. Connect to MySQL, we need JDBC. So internally, Spark SQL uses JDBC operations to work with the database here. So in Spark application side, in Spark underscore home, we need to play under Spark underscore home, under lib, we need to place corresponding database database JDBC jar file. We need to place corresponding database JDBC jar file in Spark underscore home / lib, or we need to add corresponding JDBC dependency in SBT build.sbt file. We need to do two. One, we need to place jar file in Spark underscore home / lib, and another one, we need to add dependency in build.sbt. Okay. So we have to do this one so that our Spark application is able to connect with MySQL database or any database. It may be any database. It may be Oracle. It may be any database. For any database, we need JDBC. So JDBC driver we have to place in Spark underscore home, and we need to add corresponding dependency in build.sbt, so that our Spark application is able to connect with any database or any database. If you place corresponding database driver, it can connect with any database. So today we are seeing how to connect with MySQL. So here we are discussing MySQL. Okay, let's see. I have MySQL already installed in my system. So to connect MySQL, I have one client tool called Workbench. Let me open that Workbench software. So local MySQL. So this is my local MySQL. Click on this local MySQL. In local MySQL, I have one in database called Java Hadoop. In this we have EMP salary. Let me remove this EMP salary. I don't want to this EMP salary table. So I'm dropping that table. I have EMP table. So this is the data of EMP. Okay. So this is my EMP table. I want to connect to this one. I want to connect to this MySQL database. First, we need to place MySQL connector. I have already placed MySQL connector in this location. So under softwares, we have Spark. Under Spark, this is the path. Under this, here, under I said bin, right? Lib, jars, not lib. This is jars. This one is jars, not lib. This is jars slash jars, jars. Okay, slash jars. So here I placed already MySQL jar. I am showing you MySQL jar. MySQL hyphen connector hyphen Java hyphen 5.1.38 jar file. So download this jar file from internet. Download this jar file from internet. Go to internet in your system. Go to internet. Download this jar file. Download this jar file. You will find different links. So here you will see jars download, or you will see Java 2, Java 2s dot. There are multiple links. Download that jar file and place that jar file into spark underscore home slash jars. Okay. First point, we have to place jar file, required jar file into that location. And second one, go to this Maven repository. Click on this Maven repository and see, this is the dependency. Copy this dependency and add this dependency into a SBT file. So let's start our application. Sorry, IDE. Click on this IDE. Okay. So this is our IDE, right? Next, see, first import org.apache.spark. Next, import org.spark.sql underscore. So up to this part, import. Next, to create a Spark context. Next, to create SQL context. So we created all these in imports.sql, right? So yesterday class I created one text file. In that text file I written all imports. Instead of writing all the statements multiple times in our Spark application, I created one text file. So what I'm doing, I'm loading that text file. First let's start SBT Scala cell. So it started SBT Scala cell. So colon load SQL imports .txt. SQL import, right? So Spark context is created, SQL C. So this is SQL context, right? Once SQL context is created, then this is the data frame creation. Observe this one. Observe this statement. So val df1 SQL C dot read dot format JDBC. If it is a CSV, we pass CSV. If it is a JSON, we pass JSON. If it is a XML, we pass XML. But now we are connecting JDBC, right? So read format is JDBC dot option URL. Here we need to pass JDBC server URL. So in our system, localhost colon 3306. 3306 is the port number of MySQL. Localhost means we are running MySQL server in local, same computer. That's why I'm passing localhost. Database name is Java Hadoop. So this is Java Hadoop, right? Database name. So I'm passing database name. Dot option user equal to root. Dot option password equal to Srinivas. In my system, root user database username is root and database root user password is Srinivas. Dot option DB table. So table name is EMP. What I'm saying, load this EMP table. I'm giving indication to load this table. No suitable driver is presented. Why no suitable driver is presented? So we didn't add SBT. Remember, we did sorry, Control Z. We did not add this dependency in build.sbt. We did not add this dependency. Let's place this dependency and it is internally processing. Once it is completed, you cannot get that error. Let's wait to load that jar file. So here it is processing, right? Let's wait to load that one. So it is loaded. Let's rerun once again. Press enter. So this time we are not seeing any error, right? Still we are seeing error. What is the error? SQL exception, no suitable driver. It's loaded. JDBC colon MySQL colon localhost 33806. Yep, let me remove spaces here. This is nowhere related to spaces. Let's remove spaces. Let's wait to process this one. See, it's processing SBT drum structure. Yep. Let's press enter. Yep, no suitable driver. Still it's saying no suitable driver. Mm, yep. One more time, right click on this SBT. Yep. What I'm doing, go to our Spark application. So let me check. We set Spark for Spark home. Where is our Spark home? Go to environment variable. Here, go to Spark underscore home. Yep, perfect one. So this is perfect one. Okay. So next, what I'm doing, we already added dependency, Prasad. We already added dependency. This is the dependency. Okay. Yep. What I'm doing, you can just click on uh, rebuild a project. Rebuild a project. One more time, restart this IDE. Yep. No need. Already we rebuild, right? Project. No need here. Whenever we click on rebuild, it will automatically add that one. It is not mandatory. So this is already selected that one only. So Spark SQL only. Spark SQL. Yep, we already done. No worries about that one project structure. So if you observe here, in project structure also you'll see all the dependencies added. So this is added. Whenever you click on, whenever you put on jar file in SBT, it will automatically add Suna Prasad. Everything is perfect. So whenever you add dependency here, that will added into dependencies. Yep. Let me restart one more time. IDE. Let me. Okay. Let's go SBT cell. Let's type console. Okay. Now load SQL import dot txt. Now load this data. Load create data frame by creating connection. Yep. See now successfully created connection. Only one thing here, what happened is this dependency is not reflected to our application. Other than that, nothing. I did not do anything, right? I just restarted IDE. Okay. Then df1 dot show, it will show RDBMS table records here. We are getting right. Then df1 dot select, sorry, df1 dot select star. Is it correct? How do we select? Show is the record, right? Automatically it show displays all the records. Then again we no need to select. We can use select query DSL language, right? Data domain specific language. Domain specific language. How do we use domain specific language queries? By using select, right? Data frame dot select, and we can call star or column names, right? So here what we are going to do, we are going to use in double quotes dot show. Again we need to use show. So it giving tabular structure. Yes or no? I want only employee number and salary. I want only employee number and salary. So how do we use empno comma sal, right? It will display only employee number and employee salary. Then create one more data frame. Create one more data frame with this data val df2 equal to this one. Then df2 dot show. So this is the data, and once processing is completed, then I want to display, I want to store this one again into where same database or some other location. So in same database I'm storing with emp sal. This is the different table name. What I'm doing, result data frame 2 I'm writing into database. So URL is same and username same, password same, but DB table emp sal dot save. Okay. If you observe RDBMS here, refresh here, refresh this one. So emp sal is created. Click on this emp sal. This one stored employee number and employee salary. So once we connect RDBMS, what we are doing, we are reading table and we are converting into data frame. On data frame, we did some select queries. Then we are again result we are going to store into where? Again same database. So here we are reading data from same database and we are writing into same database. Our requirement like this. We have a requirement like this. Read data from Hadoop and process it, write a result into RDBMS. Okay. Read data from HDFS, write result into RDBMS. And we may get like this. Read data from RDBMS, process it, store it into NoSQL. Requirement may be any style, right? So we did what? We performed a processing logic and finally we stored where? In database. So in Spark SQL, we can write a pure SQL and domain specific language. Pure SQL and domain specific language. So just now we written what? This is domain specific language. Domain specific language is very simple compared to RDBMS SQL, but most of the people familiar with SQL. So Spark SQL giving an opportunity, you can write directly SQL queries. You can write SQL queries. So if you want to write SQL queries on Spark SQL, we need to convert data frame into tabular format. We need to convert data frame into tabular format. Okay. DSL, domain specific language, can be used on data frames and data sets. Pure SQL queries cannot be applied directly on data frames. Then what we have to do? For this, we can create a temporary table and permanent tables. We can create temporary tables and permanent tables. How can we create temporary tables and permanent table? How do we create temporary tables or permanent tables? Okay, or permanent tables. How do we create temporary tables or permanent tables? This is our question. How do we create temporary tables and permanent tables? We can create temporary tables in SQL context or Hive context or Spark session. We can create temporary tables or permanent tables in SQL context or Hive context or Spark session. What is the meaning of this one? We can create permanent tables only in Hive context and Spark session. But temporary tables we can create in SQL context, Hive context, Spark session. But permanent tables we can create only in Hive context and Spark session. First, let's see how do we create temporary tables. So this is the syntax: df2 dot register temp table, df2 dot register temp table. Let me execute this query. df2 dot register temp table. So temporary table is created. You are seeing one warning. There was one deprecation warning. Rerun with hyphen deprecation for details. So what it is saying, this register temp table is old method. This was introduced in 1.x versions. In 2.x versions, they introduced one more method: create or replace temp view. Create or replace temp view. This is the new method. This method may not work in future Spark versions. That's why it is recommended to use this create or replace temp view method or function. Okay. Okay, we created temporary table. Where is this temporary table created? Rameshan, do you have any idea where is this temporary table is created? Prasad, do you have any idea where is this temporary table is created? We did not use Hive. Let me show our project. Desktop, quality thought, Spark SQL, batch 3, workspace, Spark SQL. So this is import. We created just SQL context. Right? We loaded this file, right? No, Prasad. We are reading file from MySQL. We are creating temp table. Where we are creating temporary table? In our Spark application. We are not saving that table result into RDBMS, right? Okay. What will happen, whenever we apply this temp table creation, or whenever you create Spark SQL application, what will happen? Observe. So here, this is our Spark SQL application, right? Spark SQL application. Yes or no? So we created this Spark SQL application in where? Inside quality thought directory. Yes or no? We created this application in where? Inside quality thought directory. So quality thought directory with this name, IntelliJ created one more quality thought warehouse. Here you will see Spark and Scala, batch 3, workspace, Spark SQL. This is created Spark-warehouse. It is created Spark-warehouse. Okay. So in this location, it will create the table. But here we are not seeing any table, right? Here we are not seeing any table. Yes or no? We are not seeing any table. Then when can we see the table? When can we see the table permanently into our location means we registered temp table, right? Then we can apply Spark SQL queries. Once we register temp table, on the temporary table, we write SQL queries. On this temporary table, we write SQL queries. How do we write SQL queries? So what is our table name? Sorry, let's start writing query. SQL C dot SQL and write select star from what is temp table 1. Temp table 1. Temp table 1. Select star from temp table 1. Dot to show. To display anything on console, we need to use show. Let's go here. Let's go idea projects, workspace, Spark SQL. Here under Spark SQL idea, under idea, yep, this is temporary table. So temporary table, we cannot see memory there. How do we see? Uh, how do we create a permanent table? So temporary table available only this Spark session. So the temporary table available only with this Spark session. To display data, to display data using SQL query, pure SQL query, pure SQL query, pure SQL query on temp table, on temp table. Okay, so this is to display data on temp table. Yes or no? Next, after that, I want to display. I want to display not. I want to create permanent table. So instead of a temporary table, what I want to do? Permanent table creation. How do we create a permanent table? How do we create permanent table? We'll see it after some time, after few minutes. So let's see. I want to display list of databases presented in MySQL database. List of databases presented in MySQL database. How do we display list of databases presented in MySQL? We use we logged in into MySQL, then we display show tables, right? Yes or no? We display show tables. From that we can see, we can find a particular table, then we can display it, right? Can we create a permanent table in SQL context team? Can we create permanent tables in SQL context? Just now we discussed. One important note, we cannot create permanent tables using SQL context. So to create permanent table, to create permanent tables, we use Hive context or Spark session. We can use Hive context or Spark session. Okay, let's go and see what is Spark Hive integration. Let's see Hive integration. So we need to add Spark Hive dependency in build.sbt. We need to add Spark Hive dependency in build.sbt. Then create a Hive context. To create a Hive context, we need to use this import. Okay, we need to use this import. So imports, SQL import. Let's open. So what I am doing, I'm using this import. Okay, next one, we need that import. Then create Hive context. So how do we create a Hive context? Means val etc equal to new Hive context. For Hive context we pass sc Spark context. Okay, for Hive context we need to pass what? It giving error saying Hive context is not available. For that one we need to import which one? Spark Hive Maven. So go to this repository. So it's giving 2.3.1. Click on Spark project Hive. Copy this one and place this one into SBT. Remove this provided only available compile time, not execution time. Remove this one. Okay, let's save. It will start importing that process. Let's wait to import that process. Yep, it is imported. Let's click once again import that one. Let's stop. And here we have already added that import, right? We added import. Then let's create this context there. Save this one and let's load. Start. Click on SBT. Click on console. Click on colon load SQL import SQL import.txt. Yep. So imported successfully. Now type HC. So we are seeing Hive context, right? Hive context is created successfully. So once Hive context is created successfully, created successfully, then to see list of databases, list of databases, to see list of databases. So it is created Hive context in this location. Go to Spark and Scala, batch 3, workspace, Spark SQL, Spark warehouse, Spark-warehouse. So this is workspace. So default workspace for Hive, default workspace for Hive in Hadoop, under root, under user, under Hive, warehouse is a workspace for Hadoop, right? Sorry, Hive, right? For Hive, this is the default, not workspace, default database for Hive in Hadoop, right? Same as in Spark, Hive, default database for default database location is this one. Okay, so this is the path. So we installed, we created workspace, right? In quality thought, Spark and Scala batch 3 workspace, Spark SQL. So this is the default workspace. Okay, so if you execute hc dot sql show databases. Currently it shows only default database. It's executing, but to display that one in console, we have to use show. So it giving error saying It's giving error saying observe what is the error. So Apache Derby access error denied, Apache Derby denied access error. So what it is saying, we need to set a security. We need to set security. Access denied, Apache Derby security, system permission is required. System permission is required. So currently we didn't create any security, right? We did not create any security. Okay. For that one, what we are going to do is, first set security here. Set security permission. Set security permission for default embedded embedded database that is Derby. Derby. How do we set that one is, let me copy this one. Access denied for permission is this one. Copy this one and pass this here in here. So here, click on this one and see how do we resolve this one. We need to set this one, system.security manager equal to null. We need to use this one. Okay. So pass this one, press enter. Now hc.sql show databases.show. Currently there are no databases. Then how do we create a database? How to create database? Let me display this one. It's showing only default database, right? It's showing only default database. Default database. It's showing default database. Result is it's showing default database. But we want to create database. How to create database? How to create database? Then we use HCL dot hc.sql create database qt create database qt. Execute this statement. Execute this statement. So database is created. Let's go this work location, show warehouse. qt.db is created, right? qt.db is created. Yes or no? qt.db is created. Then use hc.show. Then it will display list of databases. hc.show databases. It will display we have two databases. One is default one and another one is qt. Then how do we show list of tables? How do we show list of tables? How do we show list of tables? How to display list of tables? List of tables. show tables, show tables. It will display, it will display, it will display list of list of tables of list of tables of default database, default database. It will display list of tables of default database. Show tables. So currently there is no temporary table, there is no permanent table. Okay, so that's why it is not showing any tables. Okay, how to display, how to display list of tables of specific database. How to display list of tables of specific database. First connect database, connect database, then show tables, then show tables. It will display list of tables. Then we are writing this one, use qt, use qt and show tables. That's it. It will display list of tables of qt database. Okay, use qt, then show tables dot show. Currently there are no table, right? Then df1 dot df2, right? Let's create df1 dot create or replace, create or replace, create or replace temp view, create or replace temp view, table name, table name, uh, tab 1. Okay. Oh, data frame 1 is not created, right? Let's first create a data frame, create a data frame by loading db table. So data frame 1 is created. Now create or replace, create, replace or temp view tab 1. Okay, go to qt database here, warehouse, go to qt table. Here go to default one also there is no table. Let's see, show tables, show tables dot show. It's showing table tab 1 is temporary, true. This is temporary table, not permanent table. Yes or no? This is temporary table, not permanent table. That's why it is not created in, that's why it is not created in where? Inside, inside warehouse. It is temporarily created. So memory is not allocated permanently. Memory is not allocated permanently. Then what can we do to save this one as permanent table? Let's see how to create a permanent table in SQL. How to create permanent table in Spark SQL. How to create permanent table in Spark SQL. this one, save as table. Use save as table. Instead of create or replace, save as table. Save as table. Table name is table2. So save as table is not member of data frame. Let me see how do we call. It may require import or save as table creates permanent table stored in save as table. But let me see how do we create a data frame. We created data frame, right? So this one we created by using SQL. Yes or no? Let's create this one by using HC, Hive context. SQL context doesn't have permanent table creation, right? Yes or no? Then again use df1 dot save as table tab2. Still it's showing error. Let me check. Yep, we did one more mistake. How to create a permanent table. Permanent table. How to create a permanent table. So for that one, we use df1 dot write dot save as table. Save as table. Save as table and tab2. Tab2. Yep, working. Success. Super. So save as table. It's working. Then go to Qt directory, workspace, Qt directory. We are seeing tab2, right? Then show list of tables. Show tables. Show tables. It's showing tab 1 is temporary true, tab 2 is temporary false. See, this tab 1 is available until this session is available. Once we stop, it removes tab 1 table from memory. But tab 2 table is permanent table. It is always available until unless we drop it. Okay. Yep. That's it for today. And we will meet tomorrow and we'll discuss Hive related, Hive context related tomorrow. And tomorrow we'll discuss very important concepts of Spark Hive integration. Spark Hive integration. Okay. So there are some more important concepts of Spark Hive integration. We'll discuss that one tomorrow class.